Hello everyone, I'm Hegedus from Makery and I work as an Android and backend developer, so GRPC is a pretty good topic for me because it involves both of that. And I forgot this one. So what is GRPC? Does anyone heard about it before? Oh, that's pretty good. Okay, so GRPC is a remote procedure call framework by Google. The by Google part will come back later a bit, but it's not that important. So that means that the client can use standard method calls to communicate with the backend. You don't have to use retrofit or any other layer to implement your calls. You just get a standard Java class and you can do a method call and it will return something. And of course, it's a REST alternative, as I already mentioned it. So what are the strengths? It's language independent, which means that, yeah, it's language independent. Supports many languages like C#, C, Objective-C, and of course Java, which is important for us now. It supports async and blocking communication, which is always a nice thing. Two-way streaming, which will be the star of my demo. So I will talk a bit more about it later. It uses HTTP2, and here is when Google comes back. It uses Protobuf, which of course was developed by Google. And it doesn't work. Okay. So one other strength is that you have a predefined interface between the client and the server, which means that there is no communication issues between the backend and the client developer about what's the API call you have to use, what can it return, and things like that. I think every one of us had an experience when something didn't work because, well, bad communication. So what is Protobuf? As I mentioned, it was developed by Google. Yeah. It's a data serialization tool. A good part about it that generally it generates smaller serialized size than JSON because it's a binary format and is strongly typed. It's not always working. Here is a simple message. We'll see more. One thing you have to, we can see here that it is strongly typed, and there are field identifiers for every field. And these identifiers should never change, which makes these Protobuf messages backward compatible. So how can we use it with Kotlin? The sad answer is no official support. The not official answer is use Java. But of course, we can write some DSL to make it better readable. But it has a nice feature, at least in the latest Proto 3 version, that fields and responses cannot be null. But of course, the Kotlin compiler doesn't know about it by default. And you also have to keep in mind that if the backend passes a null value, then you will get an instance with the default value initialized to the default value. So this might lead to bugs if you don't keep in mind that. So the first part of writing a gRPC service is writing a service definition, which consists of two parts. Messages, what we seen before, which is the definition of the data which will be transferred. And you can think of them as JSON scheme in REST word. And the other part is the service, which is the list of RPC calls what we will be using in our client. There are four possible types of RPC calls. The first is unary, which is the basic call we all know. The client sends a request and the backend answers with a response. The second one is server streaming. In this case, the client sends a request and the server keeps the connection alive and can send data back for a longer period of time. The third one is client streaming. Is the same, just in the other direction. The client sends a request. the server then waits for the client's data to get. And the last one is bidirectional streaming, which I have already mentioned. In that case, the connection can be used by both ends, and the data can be sent in both directions. So let's see a demo. Here is a, can you read it?
Maybe a bit bigger.
Okay. Now?
Yeah.
Okay. So this is a really simple proto-file definition. We have to set a few parameters for the Java code generator, and then we can define our, I think it has a pointer. That doesn't matter. We can define our service and our messages. Of course, these are just some simple examples, but you can have a look at the RPC call, which have the keyword stream in 2 places. That's because this is a bidirectional stream. You can control the direction of the stream by placing the stream keyword in either places or both places or nowhere. And in that case, you get a simple unary call. So the setup. This was the trickiest part, I think, in my opinion. The first one is easy, just add the plugin to Gradle. Then, this is the one that is not really well documented. I mean, I haven't found any documentation about it, but luckily Stack Overflow was helpful. So then you have to configure the Protobuf plugin. There are a few, sorry, the GRPC, no, the Protobuf plugin, yeah. You have to add the GRPC plugin. And on Android, you have to add the Gergely plugin, which is responsible for only generating the client side of the code. Then you write the proto file, which we already did, and generate the sources. On GVM, Gradle generate proto, and on Android generate build type proto. So for my case, it was generate debug proto. And you have to implement the service. So the demo again. I think that's almost done. So as I mentioned, we have to add the Gradle plugin. Then we have a few dependencies to add also. And the last part, we have to set the source sets. That caused me a really lot of nightmare. And then we have to set up the Protobuf plugin. It's that easy. And the only difference is on Android that, first of all, we don't have to add the source directories. On Android, the compiler finds them by default. And the other difference is that we have to add the Gergely plugin. After that, we can easily implement or okay. After that, we only have to implement the generated abstract, not abstract, but the generated class, and we have our function, which in this case will be a chat function if it works correctly. Which have one parameter, which is a response observer. This will be used to send the streamed message from the server back to the client, and it returns another observer, which the client will use to send the message to the server. So, how can you make it more Kotlin friendly? Well, if someone used it, then you have already met the endless builders, which, in my opinion, are a bit ugly. But we can create our own DSL to make it a bit more readable. And of course, we have other syntactic sugars to do, like creating a DSL for stream observer, which is a pretty good idea because you have to do it only once and you can use it in every project, and we can use it in extension methods for maximum effectiveness, like in that case when we created a start chat function and you could use the stream observer builder by default. And we can also use our DSL to simplify the message call, which is almost the same example than the previous one, but we are not creating a stream observer, but a message. And then the last demo, which I hope will work. First of all, let's start the server and get rid of all my notifications. So, one moment, and you can see my other screen too. Okay, it is working. And I have them. Okay, you can see both of them, I hope. So let's start the client on one of them and on the other one. Oh, and it works. So this is a pretty short and easy example on how to write a bidirectional communication. On the Android side, we don't really do anything, just send a message to the server, and we will get, and the server will send this message to every connected client. And yeah, I said I will be short. So, sorry, do you have any questions?
Server and client up on GitHub?
Yes, I have both of the sources. In the next slide, you will see the address.
Nice, thanks.
Yeah.
Are you using GRPC in any live project?
Not currently, but this presentation is the result of our assessment to use it maybe later. Yeah.
Is GRPC HTTP2 only? Can you use any other transport layer?
Well, that's a really good question.
I think it is. And is HTTP3 is just a specification? It's evolving from the quick protocol. Yeah. But for now, GRPC is on top of HTTP2, so it's based on TCP. Yeah. And is HTTP2 providing the two-way? Yes, the bidirectional. Okay. Yeah. Sorry, I just didn't know where to.
Yeah, no problem.
Thanks.
Anything else? Yeah.
If you can go back to the schema definition, then why do you need that number there? So if you
Okay, so
I think it was in your idea, not in the slides.
I mean, it's easier to find there.
Yeah.
It's the client. Okay, this is the server.
Yes.
So these numbers are field identifiers. They are used by Protobuffer to identify this field. And as I mentioned, you should never reuse them because that will make this backward compatible. So if I now add a new field, I have to use another unique ID, which I have never used before. And when my backend gets updated to the newer version, it will send a protobuffer message which contains the new field. But because of the IDs, the older client can still parse it.
And does that mean that you can use different names on the client and the server and only the identifier?
That's an interesting question. I have no idea, but as I Yes. Okay. Thanks. But okay. But in my opinion, as I mentioned before, one of the strengths is. Sorry.
Probably you shouldn't.
Yeah. One of the strengths is that you have a shared definition, and you will not have communication problems. Also, if you check the GitHub, I set it up that the client uses the same file with a symlink, so they will always be in synchron. So, anything else? Then, thanks for listening, and there is the code.